Hello there. In an earlier video, we covered the basics of enabling autoscaling for your GenAI deployments. In this video, we go a step further, taking a deep dive into the advanced autoscaling capabilities now available in Bud AI Foundry. As enterprises move GenAI into production, scaling becomes one of the primary challenges. Teams need to meet strict service-level objectives while keeping total cost of ownership under control. Autoscaling is central to solving this problem because it ensures compute resources expand and contract in real time, precisely in line with demand. Bud's autoscaling is built for production-grade GenAI. It safeguards performance during sudden traffic spikes while consistently meeting critical SLOs. At the same time, it drives cost efficiency by eliminating over-provisioning and aligning scaling behavior with what matters most to the business, whether that's maximum performance, cost optimization, or the right balance between the two. By avoiding over-provisioning or unstable scaling patterns, Bud keeps GenAI deployments predictable, resilient, and reliable. And because scaling management is automated and the controls are built directly into the platform, teams spend less time tuning infrastructure and more time delivering real value from AI. Let's take a closer look at how this works. Log into your Bud AI Foundry dashboard and navigate to the Project tab. Open a project to view the models deployed under it. Select a deployment and go to the Deployment Settings tab. At the bottom of this page, you'll find the Autoscaling option. Autoscaling can be configured during model deployment, as shown in the previous video. However, if a model was deployed without enabling autoscaling, you can still turn it on later from the Deployment Settings page. Toggle this option to enable autoscaling for the deployment. Once enabled, you'll see a set of controls that define how autoscaling behaves. The controls here allow you to scale your deployment based on what matters most to your use case. You can start by setting the minimum and maximum replicas. The minimum ensures there are always enough instances running to maintain availability, while the maximum places an upper limit on scaling, helping keep resource costs under control. Next, the metric sources allow you to select the metrics that are relevant to your SLOs and define scaling thresholds for each. These include metrics such as number of requests in queue, number of running requests, KV cache usage, time to first token, time per output token, and end-to-end latency. For example, if this deployment is used for a chat-based application, you would typically prioritize time to first token and end-to-end latency. Let's say you want the time to first token to stay within 1 second and the end-to-end latency within 5 seconds. Values that are well suited for a chat experience. If these thresholds are exceeded, the system automatically scales up to handle the increased demand. You can configure any number of metrics and any combination of them based on your deployment objectives. You can also add scheduling hints to define time-based scaling rules for predictable traffic patterns, such as business hours or scheduled events. For example, if you expect significantly lower application usage during weekends, you can configure this here so the deployment automatically scales down during that period, helping you save costs by avoiding over-provisioning. These rules can be configured by selecting the relevant days, time, and duration, and by setting the target replicas for the chosen window. Bud also provides predictive scaling functionality. Toggle it on to enable ML-based predictions that proactively scale resources before traffic spikes occur. Based on historical usage data and recurring patterns, Bud automatically scales the infrastructure up or down in anticipation of demand. You can define how many days of usage history should be considered for prediction, set a look-ahead time, such as 15 minutes, and configure a confidence score threshold. Bud then predicts the expected usage for the next 15-minute window. If a demand spike is predicted and the confidence score exceeds the threshold you've defined, Bud automatically scales the deployment to accommodate the anticipated load. This approach is especially valuable for platforms in retail, fintech, and customer support, where traffic peaks are often predictable during sales events, billing cycles, or market hours. By scaling proactively, Bud helps maintain consistent response times during high-impact, high-value interactions. Within scaling behavior, you can further fine-tune how scale-up and scale-down actions are handled. The scaling window defines how long Bud observes the system before taking a scaling action. This ensures scaling decisions are made only when a metric breach is sustained, rather than reacting to short-lived or noisy fluctuations. Shorter windows make scaling more responsive, while longer windows favor stability. When autoscaling is triggered, Bud may have multiple valid ways to adjust capacity at that moment. For example, scaling by a percentage of the current replicas or by adding a fixed number of replicas. The scaling policy determines which of these options Bud is allowed to apply. If the policy is set to max, Bud selects the option that results in the largest capacity, increase or decrease, enabling the system to respond as quickly as possible to changes in demand. If the policy is set to min, Bud applies the smallest possible adjustment, allowing capacity to change gradually and in a more controlled manner. If the policy is set to disabled, Bud ignores scaling in that direction entirely, keeping the deployment size fixed even when demand or metrics change. The percent value defines how much the deployment can scale relative to its current size. This enables proportional scaling that automatically adapts as the deployment grows or shrinks. The percent period controls how frequently percentage-based scaling actions are allowed. It acts as a rate limiter, ensuring scaling occurs in measured steps rather than all at once. The pod's value sets an absolute limit on how many replicas can be added or removed in a single scaling action. This provides predictable, bounded scaling, regardless of the deployment size. The pod's period defines how often pod-based scaling actions can be applied. Similar to the percent period, it prevents rapid, repeated scaling events. Bud evaluates both percent-based and pod-based rules, applies the selected scaling policy to determine which rule to use, and then respects the scaling window and periods to ensure scaling is fast when needed while remaining stable and cost-efficient over time. Once you've configured these settings, click Save. Autoscaling is now enabled for your deployment. So that's a quick overview of autoscaling in Bud AI Foundry. By combining intelligent policies, predictive scaling, and SLO-aware controls, Bud ensures your GenAI deployments scale with confidence, without compromising performance or cost efficiency.